Well, hello, welcome everybody, and thanks for joining us tonight for our panel on Beyond Modern Data Warehousing, the journey to modern data warehousing. Kind of just talking about, I guess, with all the new things that's going on, all the different changes, all the different ways people are looking at in terms of how do we get data? How do we move data around platforms? What tools are we using? And how's it changed? So many people are coming from traditional worlds of analytics and BI, or even kind of Excel-based siloed reporting. And now there's suddenly this whole wealth of new approaches of talking lakes and clouds and scale distributed tech. And how does that actually change how we think about things? So we're having a panel, and we've got a glorious group of MVPs joining me today to talk about their experience, how they see things happening, their own journeys getting there, and answering your questions. So please, we need lots and lots of questions. If you've got particular things you want to know about how we get into modern warehousing, what it looks like, how you do governance, security, how you do certain scenarios, then please pop it in the Q&A, and we'll kind of do what we can to discuss it and get a few different perspectives and see what we can do. So without further ado, I'm going to introduce our panel. So Catherine, why don't you introduce yourself?
Yep. Hi, everyone. I'm Catherine. I'm from Norway, Microsoft Data Platform MVP. Very focused on Azure Data Factory and Azure Synapse, as you might recognize the logo on my t-shirt. So that is going to be my main focus in this panel today. So if you have any questions on that, feel free to pop them in the chat. I've been working with business intelligence, data warehousing for a little over 10 years now, mostly as an ETL developer, moving into the data engineering side. So if you have any questions about that, I'd be happy to talk about that. Other than that, very happy to be here, and some exciting news last week, so we'll probably get into that later in the discussion as well.
Awesome, thank you. And Tippy, you mind introducing yourself?
Yep, hi everybody. I'm so glad to be here. I'm Ciprian Žikic. I'm a Microsoft Regional Director and the Microsoft MVP in Artificial Intelligence and Quantum Computing. My primary area of focus is, as you might have guessed, is artificial intelligence, but I've also done quite a lot of work in big data and data warehousing for the past almost 24 years now. So very happy to be here with this great panel, and I'm looking forward to all the questions and the super interesting discussions.
Awesome, thank you. And Howard.
So my name is Howard Van Rooyen. I am the co-founder of a consultancy called Engine. We're a Microsoft Gold partner across data analytics, cloud platform, data platform, DevOps. We are .NET Foundation corporate sponsors, and I also run a weekly newsletter called Azure Weekly, which we've been doing for 6 years now. I started out probably a bit differently from everyone else on the call. I'm a software engineer rather than a data person, but I started out doing machine learning 20 years ago at university. In the second time it was cool, from the 1960s to the late 1990s, and so it's kind of interesting seeing a lot of these things are actually cyclical in nature and coming back again. And so over the last 10 years, started doing lots of big data on Azure projects, really large scale, big compute, hundreds of thousands of cores. And then as those solutions evolved, more of the value and more of the problems the business was tackling were in data. So we've been moving over the last 5 years into doing big data platforms because customers are asking questions like, how do I ingest and process 200 million messages a day? How do I monitor all the things on the planet? And you need to architect really big scale solutions in order to make that happen.
Awesome. And I kind of forgot to introduce myself. Hello, I'm Simon. Hi. But I'm sure that'll be fine. Okay, cool. Well, let's just crack on and start talking about some stuff. So our first topic was the real baseline. We've called this Beyond Modern Data Warehousing. Modern data warehousing, a bit like big data, it's a tool, it's a term that's been horribly abused by marketing in various different ways. So I kind of try to do a baseline of to everyone, what does modern data warehousing actually mean to you? So who wants to go first? Who's got a definition they can just spiel off?
I'm not sure I have a definition. I hate the term modern data warehouse because I've been hearing it for probably at least 5 or 6 years now, and it's just changed throughout those years as well. But we're still talking about modern data warehousing. So I'm assuming it means something that's newer than what you're currently working on, and then the definition can change based on who you're talking to. For me, though, it's more of an expanded data warehouse, maybe, not just the traditional data warehouse that we knew 10 years ago, but something in addition to that, whether that is a data lake or streaming processing or a data lake house, or, there are all these different technologies that we can probably chat about today. But modern data warehousing, it kind of reminds me of one of the school books I still have on my shelf from 15 years ago called Modern Operating Systems, looking at Unix and things like that. So, we might want to go into details on what we're trying to accomplish than just calling it modern. But I think that the merging of big data and data warehousing, analytics and prediction is probably a good place to start when you try to define what a modern data warehouse is.
Awesome. Any other definitions? Do you guys agree, or do you think it's slightly different?
Well, I can say that on my side as well. I really hate the term modern in front of anything in IT. Ever since I started my career, every year we had something that was modern. Modern X, modern Y, modern Z. So I think it brings a lot of confusion. For me, like the current definition of the warehousing is really along the lines of elastic hyperscale and integration. I think these are the things that perfectly define what is currently happening in the space, which basically amounts to having access to scalable resources that you can very quickly allocate or deallocate, and then integrate various engines and patterns with ever increasing ease. Like if you look like 10 years ago, integrating like an ETL process with a Spark process with a relational database was really something that was in terms of at least a 12 to 18 months project, right? With current platforms, that time to market shrinks significantly. I think that's what defines the trend in current data warehouses. Let's call them like this.
I prefer vintage or retro data warehouses. Just to,
So I might be devil's advocate then, because coming in from my perspective, the thing that's got the negative connotation in that sentence is actually the warehouse bit. The modern bit is actually what companies and organizations want to talk about because they want to modernize, they want to transform. The poison pill is the data warehouse. That's been the data entity inside their organization that's limited the business's agility for years. We're talking about organizations where you've got a large enterprise with a data warehouse somewhere in the middle, and the business wants to get a new report or wants a new insight, and because it's managed by a centralized team and it's got a model that's really brittle, it means that they've got to schedule in an engineering window that might be months in advance to try and get that insight. For me, a modern data platform, that's how we talk about it internally, is around enabling that business agility. So the real thing that's happened, I think the transition from one to the other is the separation from kind of like the compute layer from the storage layer. So all the things you talked about in terms of scaling resources, that's the fundamental artifact. But what that unlocks is business agility and the ability for data engineers to build pipelines that service use to the business. And what's great about going from that monolithic single point of failure bottleneck brittleness of a star schema or the like is building data pipelines that help generate a business insight or an outcome that can be aligned to an end user's goal, to a business unit from a cost center perspective. And also the rapidity of being able to make changes means that you can build a data pipeline and insight within a working week rather than scheduling it to be done in several months' time.
And I think there's an interesting twist there to what Simon said about vintage. I think there is one vintage term in all this, which is warehouse, right? Because it is traditionally being associated with relational database that serves as a warehouse. I think we need to get used to kind of overloading the term with the latest understanding, which means everything that can range from data lake to relational table to Spark table to whatever other form of data, right? That's one of the things that I encounter a lot with our customers who are like, well, yeah, we're still in that relational paradigm today. Well, in most cases, the answer is no, not anymore.
It's kind of interesting as well. There's that whole bottom-up view, which is kind of about the data. And I think possibly with my software engineering kind of background and, you know, building applications for customers, it's, you know, my view is always centered on what's the end user trying to achieve. And so it's really about the insight and working backwards from there to the data, rather than saying, well, here's the data we've got, it's in this pre-canned format, here's how you can have it. And so I think that is also a, you know, an attribute of this type of model. And it's that, and I think it really boils down to that notion. Is it Clive Humby who said, you know, data is the new oil? That's such a bottom-up view of the world, because as a business, I don't want to be thinking about oil. I want to be thinking about, you know, electricity, you know, because data is electricity for businesses. It's the same kind of thing, and it's the thing that went wrong with the marketing about the cloud. Is it originally was called utility computing, and utility computing is something that people understand. It's just like power or water or broadband. They just want to plug in and consume it. And the thing that has changed by calling it cloud is it's become something nebulous. And this modern data platform, really, it's about how can you deliver insights in a utility way to an organization, so that because most organizations don't really care about data. It is electricity. It's a bill they have to pay in order to do some useful work. And so if we can modernize these platforms and make it less of a big thing or a high friction part of their business, and just something they can tap into to deliver some kind of outcome or goal or insight or information that they can enact upon, that's really the value of this kind of modern architecture, is making the human being at the end of the process more effective and, you know, more productive and can make better decisions that have bigger impacts.
I think the important thing for me is the fact there's just a term for it. I almost don't care what the term is, just the fact that there's a new term for it. And yeah, modern data warehousing, modern is aged and old and all that kind of stuff, going back to Catherine's point. But so a lot of people that we talk to are the building lakes, right? So kind of there's been a big shift. People are building lakes now. They go, yeah, we're building a lake. I'm going to achieve a load of stuff. But so given where lakes came from, kind of were deliberately kind of they had very, very strong uses in the big data. You know, you're building some kind of MapReduce based thing. You're doing some kind of Hadoop based architecture. A lot of which the original ones were almost single serving in terms of the thing they're trying to deliver. I had like an unscalable amount of data that I need to boil down to answer one or two questions. And they're quite focused, because the only way you could actually answer those questions was just by putting them in a distributed storage layer. You couldn't fit it into a relational machine without paying the same amounts of money.
But isn't that the problem with MapReduce? The whole point of that architecture was you were trying to take vast amounts of meaningless data and reducing it down to some numbers that a human being could look at and grok. And actually, one of the things that's changed fundamentally is the notion that actually, if it's not a human being who's looking at the end result, like a machine learning model, you don't actually want to reduce the data. You want raw fidelity, and you want stream processing of that data at its you know, rawest fidelity. And so, you know, having completely different personas in your data platform fundamentally changed the kind of architecture you want. And going back to this notion of like the data pipelines, that's why it works really well, is you can have completely different technologies implementing those pipelines for those end user personas. And that's the thing that I think is really exciting, is the fact that you can, as you know, a data engineer or a data architect, actually start talking about architecture and figuring out different ways to implement it. And if you can implement an architecture across two entirely different stacks, then you know you're actually speaking at the right level and the technologies of the right level of maturity to enable you to do really interesting stuff.
But for me, there's a bringing together of these technologies so that there's reusability. And that for a long time, there was not the case, because the people who were doing that kind of, I'm doing MapReduce, I'm doing big data, I'm doing that kind of, I need a specialist language to get hold of something, and therefore I need to go a separate way and use a separate set of tools, are very different to the people who are building enterprise warehouses, who are doing Kimball, who are looking after giant SQL servers to serve the business and do reporting, who are very, very different from the people who are doing AI, ML, and kind of, you know, building models. So there's little bits of common language and common ponds between the big data world, like sort of the origins of the data engineering, and the people building kind of the data science models, and kind of just that was kind of became a fairly well-trodden path. but you almost always had analytics, that kind of warehousing and building a reusable model that can answer this whole range of questions, as opposed to I'm building one thing to answer this really hard question I've never been able to do. And for me, that modern warehouse is to say, well, actually, this is exactly just saying how the continuous pipeline. I'm getting in a load of data that can be used for a load of different stuff, and I'm boiling it down to make it accessible to some people, but I'm still letting the big, inaccessible, the raw mesh of data available to other people. And then I'm boiling it down further and distilling it into actual business consumable things that, and just kind of that ramp of, you need to be this tall to ride kind of thing. How data savvy do you need to be? How much specialist skills do you need to be to access the data? At the start, when you've got masses of raw data and you've stored it somewhere, you've captured it in a place that's accessible, but it's hard because it's a mess of data.
I think it's interesting, even the storing the data. So I've seen customers where they have so much data that they can't actually capture it all in their existing data warehouse, because that's already like glowing white hot and steam is coming out of all the valves because it's so close to breaching its business SLA. And so they've literally got all this amazing kind of data coming from devices and telemetry coming into the enterprise, and they're literally just earthing it like electricity because they cannot capture it anywhere. And so I think one of the core value points, going back to that separation of compute and storage, so compute is generally the costly part of it and storage is the cheap, you suddenly can scale out your data lake, and that's really the key asset, which is we can now capture all data at raw fidelity forever and a day. And we have had conversations with CTOs and CIOs who are they want to implement data science in their organization. They want to be driven and go on that kind of journey. But you talk to them and say, well, you actually need to capture at least one season's worth of data, whatever a season is within your organization. It might be the cycle to Black Friday in retail, or it might be a financial year, or it might be a trading cycle over a 3 or 4 year period. But you need that corpus of data before you can do anything interesting, because you need to be able to spot the patterns in the data. So first you need to capture it. So the level one is put your data lake in place, capture all your data in its raw fidelity, which is again the kind of opposite of a data warehouse, where some core team have already predefined what the schema is going to look like, and all the data loses its fidelity to munge into that kind of agreed data dictionary. And from that point on, you've lost some of the most valuable aspects of your data, having processed it into an accepted form. And I think that's one of the interesting things about organizations as they're evolving and transforming is that central view of its data relevant anymore? Or are you, with a modern data platform, evolving towards what we were doing in kind of applications in terms of building APIs that talk to different business units in different domain language depending on who the end user is? And so, having worked with some customers in the telco space, the customer team want to basically build a signals library that give them interesting insights into their customers. So, has their quality of service dropped? Are they likely to churn? All these things are interesting signals that come from a variety of sources, but they can't get that from the data warehouse, because that's not what the data warehouse is designed to do. They need to augment those data, enrich them, run models against them in order to then create a data point that is now interesting and useful for them.
And that still holds true for that. That paradigm of, you store all your data in a lake, you boil your data down in a lake, and then you present a distilled model for some people and an undistilled model for some people. And the difference is, because of constraints of infrastructure, because of constraints of the database, you have to throw that data away previously. You're loading data in, you've got your traditional BI or stage clean warehouse kind of schemas in a database, and you truncate the stage and cleaning time to keep things small. And now say, well, actually just strip all that back. That's just lake areas with various amounts of distillation happening, keeping the stuff as it came in, so you've got your immutable delta of what do they get in the first place, but actually allowing people to access it at different stages of that data pipeline. So for me, it's still a transition. There is still a journey that data is going on, but not everyone gets data from the end of the feed. Some people are going to the start, the middle, the end, depending on your use case.
So how have you seen, as people have been in the data world for the majority of your career, how have you seen the change happen in the last 5 to 10 years from the skills that you used to have in the previous kind of when it was more BI than analytics and data science?
Happy to go. So for me, there has been a big skill shift. You know, we're talking about I'm moving away from everything is SQL and stored procedures, and I'm curating, essentially hard coding all of my transformations. You know, if someone says I've got a new bit of data to load, I either write a new store proc or I generate a new SSIS package, and it's very, very tight, very fixed. To onboard new data, you deploy new code, and then you can push it through. So certainly for us, it's been a very big journey of going, you know, I'm going to build, you know, there's the whole ADLA route. So, you know, you apply code. And so we're starting building things that do schema generation. You know, so I want to generate a script and then run the script on the fly. And so we started just doing like sort of code generation, but a runtime rather than deployment. And then these days we've gone entirely Spark and everything is metadata driven. So I can build one script and then just run that 1,000 times with different sets of parameters to process data. And then onboarding new data is metadata change. It's parameter driven. But that is a mindset, and that's very much us shifting more towards building applications, data applications. But obviously then, you know, you have kind of much more your traditional application management side of things. You're having to worry about how are you doing unit testing, what's your coverage, how are you doing automated deployments, how are you keeping those libraries up to date and dependencies across different environments. Things that you didn't necessarily have to worry as much about back in the days of looking after a code footprint that big, but that was all fairly simple code. Now it's looking after much less code. The code footprint is tiny compared to what it used to be, but there's a much bigger complexity. Therefore, the technical barrier to adoption has grown. So kind of we tend to find ourselves kind of we're taking a lot of teams through the journey of going, all of the stuff you know, all of the things around data and ETL and data quality and data management and managing different data sets and slowly changing dimensions and all that kind of stuff for us is still absolutely relevant. You can use all of that good data management and ETL. They're skills that are actually fairly hard to actually come by. They tend to be experience driven. And then there's a whole bunch of tech, learning whether it's Scala, Python, Java, whatever it happens to be, but there's probably a lot more programming involved than there used to be. And that's a big shift that we found. We found a lot of people are fairly intimidated by it. You know, you kind of been in a little bubble of working in your nice, happy SQL warehouse, and you know your tool stack, and the tool stack changes every 2 years, and you're like fairly happy going, oh, there's a new release of SQL Server already. Oh, it must be what 2018. Suddenly now it's every month, especially with all the cloud solutions. There's a much faster cadence. There's a much faster pace of change. There's a much wider, broader technology stack for people to adopt, and so it's more people getting tech wise and just learning, how do I do the thing I always used to do, which is in this new language, not knowing what do I need to do, which has definitely been an interesting shift. But then actually learning that tech isn't as hard as people think it.
Can I just, on that last point, can I just ask, so is everyone on this call, is everyone a consultant, or does anyone actually do this as their primary job for an organization?
So I'm currently working as a consultant, but I had about 5 years working in-house in the BI team. So I've had a couple of different experiences there. But I can only echo what Simon just said, that there are some things that are at the core of the data engineer, ETL developer, in terms of skills, is understanding the business. You need to understand what the business does, what they want to achieve, which questions they want to ask, and the answers that they're looking for. That is basically what you're providing. The tech in that case is pretty much irrelevant. Like, you could use all different kind of tech and stacks and approaches. Your main job is to get the data to the people who need it, so they can answer the questions that they have. So that skill set, I think, it hasn't really changed for me. You need to be able to translate business requirements into a solution. But then, like Simon said, things are changing quickly. Like when I started, and Simon mentioned this earlier as well, as you had to generate SSIS packages or write stored procedures or do something, and now it's just a whole different world. And for me personally, it was a big change. I was very comfortable in my world of SSIS development, ETL development. I spent the first 5 years learning the ins and outs of that. And only when things started to move did I realize that the best practices, the approaches, were all based on the restrictions that you had back then in the tech. I was like, Right. Okay. So the reason we're doing this, the reason that I was taught that this is the best practice is because it was pretty much a workaround, because you had these constraints, right? So a lot of that has been removed now. So you have a whole different world, but that also comes with, you know, a whole different world of challenges, because now you can pretty much do everything. So now you need to figure out what's the right approach. How do I do this? And it all comes back to, you know, answering those questions that you have. And again, tech isn't really that relevant. You can learn a new language, you can learn a new platform, you can learn a new stack. The whole point of this is just to make sure that business users, end users can consume data in the format that they need, whether that is a data warehouse or whether that is streaming data, or if they need huge amounts of raw data for some kind of purpose. You really do need to tailor the solution to that. And I saw also in the chat or in the Q&A, someone asked, are star and snowflake schemas obsolete now? And I'll say absolutely not. Not at all. There are still many companies, many end users who need that kind of prep data, who need a very, you know, very small, specific star schema to do reports on that, to do dashboards, to do some analytics on that. But it's not the only solution anymore. It's not the only thing that you deliver anymore, because you now have all these other things that you can, you know, deliver in addition to what you could only do before because of the tech constraints, pretty much. So I think what we see right now is there might be a change in skills, but it's more expanding the skill set that you currently have.
Yeah, and so the question I asked last, I just wanted to drill down a little bit into learning, because one of the things that I think that I see a difference in the real world is that you know, consultants, you earn your living by having the best skills to teach and to deliver. Whereas most of the customers you're helping, they have a real job, which, as you say, is running the process, delivering to deadlines. And so their bandwidth for learning is so much more constrained than the consultants who are generally brought in to help them transform. And so one of the things I think is really kind of interesting, like specifically like for Synapse, is actually the focus on the transition and continued use of the skills you already have in languages like SQL and C# and not just the languages that you know, but also the you know, internal IP that your business may have developed in order to do data translation or running algorithms or whatever. You can basically lift and shift those workloads. So the impedance of adopting a new technology platform is actually kind of leveled, because the thing that we've kind of seen is, you know, is the shock of, so we've got to come up with a new data platform, we've got to adopt new technologies and tools that are a completely different way of working. You're asking me to learn at least 2 new programming languages, generally in terms of like Python and Scala, and somehow I've got to do this while still supporting my business with all the things that I don't have time to do already, and all the technical debt that we still haven't paid off. And so, you know, there is a real difficulty in making the leap to a new platform. And yeah, we've seen teams that it used to take them 6 months to build a new report for the business because of all of the workarounds that you were talking about, all the friction, all the technical debts. And they can see that in this new world they could be much more productive, but actually the amount of effort that's required to go from the old world to the new world is quite a massive leap as well. I don't know if that's been your experience.
Yeah, absolutely.
The way I've seen it in the past year is like, I see it like a clash of 2 words. I had the chance to work very closely with the Synapse Analytics engineering team in Redmond to train the top Microsoft employees as well as the top partners in Synapse. And it all depends on the direction you're coming from, right? To oversimplify it, it's a clash of SQL versus Spark, right? And it works from, what's really interesting, it works from both directions. So you're coming from the SQL world, you're in for 2 big shocks, right? The first one is the transition from the, let's call it classical relational engine to the MPP-based relational engine, the massive parallel processing engine. Most organizations did not have before SQL Data Warehouse and now Synapse. They were really not having the budget to go into MPP appliances. So the most you could typically get was maybe a cluster of beefed up SQL servers, right? But that was like mostly all. Now, all of a sudden, you're exposed to a world that seems to be relational, but where you need to think about distributions. You need to think about all sorts of new types of indexes and their implications. So that's the first shock. And then the other shock is things you were trying to solve in the SQL world, like you were banging your head against the wall, writing like 2 days of code and doing all sorts of weird things. You get them sorted out with a Spark notebook. And it's like, interesting, right? So all of a sudden you realize that that world that seemed to you so far, which was the weird, the data science-y, big data guys that were writing on that stupid Python language, right? All of a sudden you realize that some of the real life problems that you had are so easily solvable, right? Using a Spark notebook. And obviously that's a statement that oversimplifies things, because behind Spark is all the distributed data frame processing engine and so forth. So it's really powerful, right? But you're in a big shock. But what I've seen, and I have to tell you, it was a very interesting experience, is the same shock coming from the other way. As like I've seen super strong Spark developers, right, that were like, dude, can I get a quick response from a relational data warehouse that has 500 billion records in a table? They were like, I didn't know a SQL engine can do that, right? And the reality is that these worlds started as being unbelievably different, right? The classical relational model versus the initial MapReduce that was the core of Hadoop. What's interesting to me is that they are slowly converging, right? They're still very far apart. They're rather different paradigms, but at some point in time, the differences will start to kind of fade away between these. So what I see today as the #1 challenge, and I think from that point of view, I fully agree with what Howard says, is you get more and more pressure as being an employee that needs to do his or her job. You get more pressure to expand the skill set, because say until maybe 5 or 6 or 7 years ago, it was just fine to play the I'm the SQL god of the company, or I am the distributed big data god of the company, and everything should be kind of morphed through the lenses that I use to see the world. Now it becomes increasingly clear that some of the problems that you need to deal with can be solved with a different paradigm, with a different world. So I see this increasing pressure on professionals in the data space to start expanding their skill set, which is way harder to be done than said, right? Because you have tasks, you have deliverables, you have those 100 data sets that you need to take care every day, each of them generating errors and problems and tens and hundreds of packages of ETL and so forth. So that's a very interesting pattern that I see like across the industry. And what's interesting, I see it in both technology providers, right? Like, for example, Microsoft, right? Microsoft people have the same pressure internally to start understanding more, but also on the consumers of technology, which are all the enterprises and companies in the world that use these types of technologies. So that's going to be a challenge in my opinion, and probably it's going to be among the top 3 professional challenges in the data space, probably for the next 3 to 5 years.
Can I just?
But it does seem to be a centralization of this kind of stuff. I mean, regardless of where you sit, whether you're on the Spark side, there's been huge things this year and last year with Delta, and which is essentially saying, you know what, we're going to bring in lots of the nice SQL things. And there's a massive celebration a month ago when we got constraints on a table, and everyone's like, yeah. And then on the SQL side, everyone's like, really? Wait, that's a big thing. But essentially, SQL on the Spark side, they're moving to adopt more and more the known maturity that you get in traditional relational services. On the relational side, they're adopting to go more and more of the distributed, kind of like the more flexible, the more schema on read kind of way. And essentially, from what I see, there does seem to be a convergence in, it doesn't really matter where you sit, we're kind of all heading in a similar direction.
It's really interesting because you've both gone down to kind of like the technology implementation level, and the thing that really the bit I wanted to talk about was just the one word that you said, which was notebooks. I think notebooks are the game changer. It doesn't matter what the technology is underlying it. We have a new type of IDE, and it fundamentally enables a different type of collaboration than we've ever had before across data or software engineering, or software development. The ability to basically have an executable OneNote that you can merge in your documentation, screenshots, videos, ideas, sketches, and executable code and data, I think is the biggest game changer to hit this industry in the last 20 years. And I don't think enough people have jumped on this technology. And so notebooks are available all throughout Azure now. They're in Cosmos DB, they're in Synapse, they're in Databricks, they're in Data Explorer. The .NET team have got .NET Interactive, which is absolutely fantastic, meaning you can run notebooks inside VS Code. It is a beautiful experience, and we did a data hack about a year ago, and it was a game changer, and because we had sat around the table a CTO, a pensions data expert, a data person, and a programmer. And they were looking at a data process they'd had in the business for 25 years. And this is a company that's 100 years old. So they've been around for a long time. And this process that's 25 years old was last written in Access or something like that. And it took them on average three months, 12 weeks to onboard new data into this platform. And getting people around a table, sharing a notebook where the business person could write out the business rules, the pension expert could basically say, here are all the different validation rules that we have to apply as a business. The CTO basically understanding what the whole end-to-end process was and how much things cost. The data engineers basically saying, here's a really efficient way of processing that data. Meant that we took that process that took 12 weeks, we got it down to 45 minutes. And that is a fundamental game changer. And that the end result is a massive win, but actually allowing 4 different people from different teams to collaborate together on a problem that's a business domain problem and solve it together, I think is fundamentally the game changer. In software engineering, the big thing that's helped us in the last couple of years has been behavior-driven development, being able to talk about the situations and scenarios and behaviors of the systems you're trying to develop. And notebooks kind of allow us that similar way of talking English to people, and in languages they understand. So the software side of it is just one little cell with some code in it. The business domain expert doesn't need to know about that because he just knows that's the implementation of the rules that he's written out above. And that, I think, is a fundamental game changer. And the more organizations that can adopt notebooks as a way of conversing, collaborating, I think the bigger the impact can be. And as a side, that little data hack we did, it was so impactful that the CTO actually decided to stop being a CTO, and he went and did a data science master's because he could see the power that all this kind of technology could do to transform a business. And he's now a full-time data scientist. So I think it can be quite revolutionary for people.
Yeah, absolutely. And that's it's kind of what I said earlier as well. The important part here is the business, the questions, the answers, and notebooks, like you said, the collaboration, bringing in people from different backgrounds, different experiences, working together on that. You're focusing on, delivering what you need and not the tech itself. And I mean, I'm a tech geek. I'm a super geek. I love the tech. I love digging into that. But my job, whether it's in-house or as a consultant, is to, deliver value, the business value. And notebooks is a great way of just focusing on that and communicating, collaborating around a specific problem or challenge that you want to solve.
I mean, so that is a question in terms of, so bringing together people in terms of ability to do data analysis and ability to do kind of a little bit of kind of data engineering kind of code kind of things. Notebooks is a great example of that. And certainly having a common platform underneath it and common languages that we use to query that stuff, absolutely. Have you guys seen in terms of the third piece of the data triumvirate that is engineering, analysis, and data scientists? How much have you seen that story change with these modern architectures? Have you seen data scientists get slightly more integrated with those stories, talking more to the warehouse guys, the analyst guys, the engineering guys? Or is that actually still that slightly separate story in that the engineering and analytics is kind of coming together and data science isn't necessarily much of that party? What have you guys seen?
Well, the interesting thing that I see through the industry is that despite the promising messaging and the optimism in this area, I believe we're still in the era of what I used to call throw the model over the wall, where the data science part is still a silo from many points of view, right? Data integration is one of them, but also mindset is the other one. And I don't want even to touch the elephant in the room, which is CI/CD, or what we call it with such a sexy name. We call it ML ops, right? As there's still a lot of wishful thinking in the industry in that particular area, and that's another big challenge of for the coming years to integrate that process, that silo that data science currently is. Now, the notebook, the Humble notebook, also does a lot of good in this respect, because it unlocks a lot of let's say a lot of potential, a lot of possibilities for, let's say, the mid ranks and the lower ranks of the data science world, right? Data science all of the sudden is not reserved to a few mere mortals that can discuss in terms of deep neural network weights from 8 a.m. to 10 p.m., right? We're starting to unlock scenarios. And then the other thing that is a positive trend in my point of view, it's still in the early stages, but it's good, is the capability of actually easily reusing what the data scientists produce. And the fact that you can now literally incorporate a model, a trained machine learning model, into a relational table, right? And then run predictions in the relational space using a trained machine learning model is a big step forward. So there are some encouraging signs, but I still think that there are some serious challenges, and the number one between these challenges from my point of view, as I said, is the operational part, is the CI/CD pipeline, where you need to address those difficult problems that data science brings in, right? Because when you think about it, all of the sudden, all the operational pipelines are not about code anymore, right? They are about code plus snapshots of data. That's one of the things that I saw kind of break a lot of organizations when it comes to integrating the data science part and the data science pipelines. And then finally, there are the modern challenges and that's a place where modern is a suitable word to use. The modern challenges of machine learning, where you're thinking about fairness, you're thinking about explainability, you're thinking about confidential computing, you're thinking about protecting the personally identifiable information of people, right? So those are changes that have challenges that have originated in the space of machine learning, but they are kind of fanning out into the whole world of data platforms, right? It's one of those things that machine learning has brought on us, if I can use this term, and all of the sudden we need to deal with them from the very early stages of most data processes. And that's another interesting thing that I see throughout the industry happening when it comes to data science integrated in the data space.
And I think that data engineers, as a community, have benefited massively from the investments in machine learning, because it's been a long time since we've had huge investments from all the big tech companies in terms of data tooling, ETL processes, ETL libraries. We might, most end users may not be doing machine learning, but they can benefit from the tools for doing kind of standard ETL jobs, and that's a massive boon as well, because it's a massive modernization wave that is actually coming through. You can just take, one of the unsung heroes that I absolutely love is the Microsoft Data Prep library that came originally from kind of like the machine learning workbench, and it uses huge amounts of amazing tech under the covers for doing kind of machine learning, generating machine learning models, all the pro stuff that's in Excel, and you incorporate that into kind of your notebooks for just doing ETL, and it massively optimizes and delivers value. Your time to value shrinks massively, but that wouldn't have existed if it wasn't for the investments in the machine learning tooling, because they're trying to build a new set of products. But the question is, how do you use all of these services in your day job if you're not doing machine learning? Or a notion of like, the democratization of machine learning is, I don't need to be a data science in order to run these models. Azure Weekly is a really good example. Is I started doing that newsletter 6 years ago, and I spent my entire Saturday and Sunday going and finding all the articles, reading them, and then adding them to a newsletter. And then after about 3 months of that, I got sick to the back teeth of doing it. So I wrote a tool, and it then passed all the RSS feeds, and then I was one step closer to having an automated newsletter. And I thought, well, now I can probably create an algorithm that can do text classification and bucketing for me. And so then that was the next stage. And so literally by the end of that process, all I had to do was double check all the workings and do the editorial. And then when the ML.NET team produced AutoML, which is just a CLI tool that says, here's your data, here are the columns of data I've got, which one are you trying to predict? It went away and built a much better text classification model that was like 96% accurate compared to the kind of heuristic that I'd built. And so you can do amazing stuff not even having any deep understanding of machine learning or data science by applying the tools. And I think you're seeing this now with pre-canned models in Power BI and other things like general models like anomaly detection, things that actually solve real business problems, just being surfaced in the apps. Because most organizations do not have a data science team. They do not have an AI team. They have a bunch of overworked business analysts who have outgrown Excel. Their big data problems are they can't fit all their data in Excel anymore, or they can't build a pivot table big enough. And so they really need new tools in order to answer the questions for the business. And that's what I think things like notebooks and learning Python, it gives them a gateway out of being trapped in Excel. Even Power BI, it's got so many features and languages and M and DAX in there that allow them more power than they've currently been used to. They can do data engineering as an information worker, much further down the value pipeline. And I think that's a massive boon for productivity, is giving them the tools that essentially the actual kind of engineers used to have. It's got a nice UI on it to help them do things effectively, but actually under the covers they can quickly go and learn a little bit of scripting, like they did when when spreadsheets were new and they had to learn a little bit of VBA. They weren't programmers, they were just end users. So it's amazing if you can make it a gateway drug into learning a little bit of Python or a little bit of R. It's amazing how once they get confident they can build more and more skills in the area, and it stops being something scary and daunting, because machine learning is a scary thing. It's data science is a scary thing, but when you actually drill it back down to the scientific method that we all learnt at school, it's not really scary. And notebooks are the lab notebooks that we had in school when we were doing the scientific method in chemistry or biology or physics. And that's it. Essentially, it's just going back to some of the fundamentals of good practice and good process and good hygiene, and things like CI/CD. These are all, again, things that have come from software engineering. How do you manage things at scale that are complicated? You have to put processes in place and you have to automate them, because otherwise you've got human error and variability. So behavior-driven specifications, executable specifications are a fantastic thing for improving in that area. But also CI/CD, DevOps, the notion of DevSecOps, because if you want to talk about security, you have to start at the beginning of the process, which is how you build, test, deploy these code changes into an environment and have traceability and security around all of that. These are all the skills that people are having to learn, and that's kind of, it's not just the tech now, it's all the processes that they've got to learn in order to operate within that modern environment.
So I want to pick on just one of those points in terms of that, the scariness factor, right? You're put off by trying these things out because it's scary and new. You don't know how hard it is. It's data science intimidating stuff, or it's data engineering, or it's DevOps if you've never tried it before. So much of kind of these things are a little bit daunting. But it used to be, you can't just try out on a whim, right? You can't go, oh, I'll try it, but I might not be any good at it, and I might, because that used to be a massive investment. You used to need to spin up some kind of infrastructure, some kind of tech, some kind of thing. I think one of the benefits of the fact that we're getting so many more built-in things, we're talking about a common platform. We're talking about using notebooks anyway. So if you're going to do a notebook to do your kind of data engineering pipeline preparation to get your data right, plugging into some other Python or Scala or R libraries, actually, you can give it a go. You can try it. If it doesn't really work, you can throw it away, and you've not really spent any money. The barrier to entry for all of this stuff is drastically lower in that you're not having to invest in a tech, spin up a load of infrastructure, do a load of pre-work. You can try it out really cheaply and quickly, which means people are more likely to try it out, which means people are only going to go, cool, that's not for me, fail fast, nice and quick. You've made a bad decision and you've pulled back and you're not stuck down that path. Or you go, oh, hey, actually, that classifier works. I'm getting some benefit from it.
Or you don't need your manager's approval to get budget to buy the hardware in order to experiment, do that experiment 6 months down the line.
Exactly. So, I know that's made a big shift. I'm very conscious of time. I think we've got 8 minutes left. So I've got some rapid fire questions to throw at you guys, just to get kind of quick responses on to see what we think. In this modern world, obviously, Synapse wasn't the only thing that was announced last week. We had this crazy thing called Azure Purview. How important is governance in modern data warehousing or modern cloud data unified analytics platforms, whatever label we want to put on them?
I would say it's very important to those people for which it's their job, in terms of, am I in a regulated industry? Do I need to understand what risk is in my data? Do I need to understand what PII is in my data? Do I need to understand how to address incoming requests from customers to have their data deleted? Where is that data? Where does it exist? What format is it in? And part of the problem is not having any of those tools. And so Purview is, I think we had this debate on Twitter. I think it's actually quite a good name for a product, because data governance is the purview of some people within an organization. And in the same way that we've grown counting like data scientists and data engineers as terminology, it's those business users who are responsible for not the technical aspects of data, but the legal and the regulatory and the business aspects of it. They've now got a tool in order to understand the landscape of what it is that they are responsible for, especially in terms of legal frameworks where they could possibly be the person who ends up in court, goes to prison when things go wrong.
Catherine?
Yeah, and for me, coming from the more of the data engineering side, it's another tool that can help me in my job. It's another tool that I can use to talk to business users, to kind of automate some of the things that I've spent a lot of time building previously, with building out my own, set of rules and documenting those, and having that kind of data catalog on the side, having that built into the tool, again, bringing in all of these different kind of roles and users into one platform, I think is a huge thing. And governance is important, like Howard said. I mean, if you can go to jail if you don't do it right, obviously it's something that you need to focus on. But it's it's critical and important for some, and it's helpful for others. I don't see anything negative with it.
Okay, and Cyprian, what have you seen? And certainly on the data science side, is that kind of stuff useful or prohibitive for data science?
So in my mind, when I talk about governance, I always think about people, processes, and responsibilities, right? So I would say the importance of governance increases exponentially with the size of your organization and the number of data processes that you run. That's in a nutshell the way I see it. So reach a certain size or a certain number of data processes, I believe you cannot kind of survive without proper governance. It's as simple as that from my point of view.
I mean, for us, it's about avoiding duplication. You know, it's about kind of in so many of these tools, we've talked about making it easier for people to land their own data, to try something out, to experiment, to grab a load of stuff, try something. If it doesn't work, cool, try something else. And certainly, you know, kind of in the data science kind of projects that we do, and there's so much of the work is prep. So much is getting the data, doing some cleansing, getting it in the right shape, pulling it in, munging it around with some other data to try and find out where the patterns and things are, and saying, oh, where have we got customer data? And time again, you get data scientists either trying to go to the warehouse and then going, no, the warehouse is too refined, and then just going off and trying to find where else in the business they've got that data. So that data discovery piece is just always been a pain wherever we've gone. So there's massive regulatory, you have to do some data governance. There's a level you have to do. If you've got PII data, you have to know that you've got it. But there's just so much benefit you can get by doing it right. And it's really hard to do right. And the number of times I've just seen SharePoint lists and just people whose job is forever entering and maintaining data dictionaries, any chance to do that in an automated way, in a consolidated way, in a way that just sets from all of your different potential silos and goes, this is what's out there, is just massively useful. But also could, you know, it can turn into a data swamp of its own if it's just, well, here's 1,000 different things that contain customers because it's too late. It's already a massive mess. So it needs organization, it needs work, and it's a huge amount of effort to do it. But if you do it right, it is so powerful. But it depends where you are on that journey.
On that note, I just want to make a quick remark here. I can tell you from my experience that in any super cool data science project, the actual shiny data science part is in most cases less than 10%, usually less than 5%.
Yeah.
All the rest of it is data prep and processes. So that speaks tons.
Yeah, that's one of the questions that we had is, what are the skills I need to be a data engineer? And again, we are on a time budget. And I'm going to add, who makes better data engineers? People from a software engineering background or people from a data background? Deliberately to poke the bears.
Good communicators.
Yeah, communication. It's understanding the tools and processes, and the fact that as a professional, you need to build feedback loops to improve yourself and those processes. And that's possibly the most important thing, which is, especially when you're engineering data that flows, you know, things change, things change, tools change, data changes, and so it's never one and done. It's a constant evolutionary process. And so making that feedback loop as tight as possible and giving yourself as much information, as much processes, as much documentation as you need in order to make that happen, I think is possibly one of the big differences between data engineers and software engineers, who generally, you know, write a spec, write a unit test, implement the code, and it's done until the context changes. I think with data processes, they are living, changing beasts, and you're only really done when you've put every different type of data permutation through it, and that's generally a lot more complicated.
And then throwing
I
in two very specific things in there. If you know SQL and you know something like Python, you're set for many years, I think.
Yeah, and I think it doesn't really matter where you come from. I think the number one skill that you need to be a good data engineer is attention to details. If you have that, I think you're quite well prepared to be a good data engineer. I think anything else can be learned. That is something attention to details is something you're born with. You either can or cannot do it.
I think I used to have it, and then years of consulting, my attention span's just shredded. Cool. No, and that is good. There's a variety of things, and I think that is like a super important answer, I guess, for all the people watching. And we get tons of those questions going. How do I become a data engineer? What are the questions that, what are the skills I need to learn? What path do I need to go? What do I need to study at university to make it to the point when I can do data engineering? And there is there isn't that set path. And kind of, I think everyone kind of just says there are tech skills, and there are people skills, and there are process skills, and certainly understanding data management makes a lot of sense. Certainly understanding some of the software engineering principles, and the better data engineers are applying more and more of that to say, I'm spending less of my time testing. I'm spending more of my time building code that's reusable. I'm not actually writing, if I'm trying to fix a date, I'm not doing it at a different time every time I come across that. I'm just writing a little utility, and I should call that programmatically, and then my life gets easier. There's like tons of things we can learn from all these different walks of life. The people that we've seen make the best ones are the people who are just curious and going out of their comfort zone and learning from what do they do out there. I mean, TDD, can we apply that to data engineering? Not always, but actually we can learn from it. We can actually start to bake it into some of it. We can start to build some libraries and frameworks that are repeatable and bring in some of that different stuff.
Or understand that actually something like TDD, its entire point is to reduce fear and reduce the fear of change. And that's really the underlying principle. If you can reduce fear, then you can make changes, and the friction of making changes is reduced. And these are all the core tools and process you need to have, which is how can I kind of be fearless, but not reckless? How can I be productive without causing lots of harm? And so those things I think are very cool.
Okay, I think are we on final question, and then I'll kind of end things up. Where would you like to see things? Just real short. If we're going to say, so all the modern data platform type stuff, what would you like us to be calling modern data platform in 5 years' time? What does it look like? How do people use it? How do people interact with it? What do they need to do? In a couple of sentences.
Let me start with that. A very short one. Full convergence between relational, Spark, and machine learning.
Easy as that.
I would like it to be a service that the business can pull down on and use and adapt and change. And it's just another thing. It becomes as ubiquitous as email inside an organization. It's something they can count on and use, and isn't a huge point of friction and pain, and just is a thing that allows them to be productive.
Yeah, my dream is to basically make myself redundant. I want these tools to be good enough for everyone to be able to build solutions to get the answers that they need without having someone working full time building that pipeline. It's a big dream, but that is the dream to get to that kind of advanced technology and tools that we can use.
That's good to know. Our future vision is we don't want to be doing this job anymore. Awesome. Well, it was great for you guys to join me, and I hope everyone got a lot out of the panel. Again, fire in more questions. I think we shared everyone's kind of details on Twitter and whatnot. Feel free to shoot more questions over, and we'll keep answering. I think otherwise we'll call it there and say good evening. Thanks everyone for joining, and thanks for taking part.
Thanks very much. Thanks, Simon.
Thank you. Thank you.
For hosting.
Bye.
Bye.